So I put odds and ends up at the top because we have done a lot of section 4.1 through 4.4. I don't particularly care for how the textbook does it, so I do a lot of handouts. I have a logical progression. Now I'm going to jump back in the textbook to pick up some odds and ends as I write. And so this was the first one, was even and odd trig functions. And I even tell you what page number, 467, in case you want to look it up later or whatever. So I'll be assigning textbook homework today. Next, we need to learn about our first trig identity. Well, you've actually already done some trig identities. Trig identity, like sine, is 1 over cosine. That's an identity. So let's do this trig identity. This is critical. So you might want to have this sketched. It's a quadrant 1 reference triangle. I can tell it's from the unit circle because it's centered at 0, 0, and the hypotenuse is equal to 1. This trig identity that we're going to do here, actually we're going to develop one, and then we're going to come up with 2 more, and these 3 are used so much. Most especially in chapter 5 when we get back. The proofs. I call them proofs. They're really called verify identities. So this distance is called what? I mean, just x, right? Then this one's called what? Y. And what kind of a formula did you use in geometry could I use on this? Pythagorean Theorem. So that's x squared plus y squared equals 1 squared, which is 1. In fact, that's the equation of a circle centered at 0, 0 with a radius of 1. The one thing, though, that we noticed is when I do have this unit circle, this reference triangle, isn't that ordered? Okay, so that's my ordered pair xy. But we also know that this ordered pair xy, it's cosine theta, sine theta. So that means, in other words, this x value is really cosine theta, and that this y value here is really sine theta. Do you agree? Okay, so what geometry theorem did you use here? So now I'm just going to do Pythagorean theorem over here. On a trig function, when it's squared, you put it between the word sine, cosine, tangent, and the theta. It's very awkward. This means this. But they don't write it like this. They write it like this, which can be confusing. But this is this. This is just how they write it. There is your first trig identity. Commit this to memory. You will use this so much. You will use this so much. Not here necessarily. We're learning little bits and pieces in 4.1 through 4.4, and then we'll start to graph the rest of 4. But then from then on, when we start just doing math with trig, chapter 5, we just start doing trig, and then next year in calculus, you do trig. This thing here is used all the time. And it's not that hard. If you can remember this, and then if you know this, you just use Pythagorean theorem on both. So this is our first one. In fact, these are called, I can spell, Pythagorean identities. Ooh, I just made it plural. That means I need more than one. So let's come up with the other 2. Let's come up, so this is our first one. I'm going to come up with another one. I'm going to take this, and I'm going to divide it by, let's say sine squared theta. I'm going to divide it by this, all the way across. What I do to one side, I can do to the other. On both sides, I'm dividing by sine squared theta. So let's clean this up. What's cosine over sine? I'll wait. Almost. So this is cotangent squared theta. What's sine squared theta over sine squared theta? 1. What is the reciprocal of sine? There's my second one. Then I have one more. I'm going to go back to my original. Cosine squared theta plus sine squared theta equals 1. What do you think I'm going to divide by this time to come up with my third one? That's correct. I'm going to divide this time by cosine squared theta. I'm going to travel this way to get it. So what's cosine squared theta divided by cosine squared theta? What? 1. Plus, what's sine over cosine? Tangent, but they're squared. So it's tangent squared theta equals what? Secant squared theta. There is my third trig identity. For me, I am someone who doesn't memorize very well, but I'm logical. I only memorize this one. I just know how to get to the next two. Divide by sine squared theta to get one, divide by cosine squared theta to get the other one. So I only remember this one because it's the easiest one to remember, and I just know how to get the other two whenever I need them. You need them a lot, but not nearly as much as this one. So that's the homework so far. And so let me see if I can find a problem that will fit for this. Let's see, 4.2. And 19 through 24. Nah, I don't want to do that one. Oh, I'll do that one. I'm actually going to choose one of them out of this one here. I will actually choose 29. Here's 29. So in 29, here's the problem. It says use this trig identity to find cosine of t. So instead of theta, I would just put in t. It's just a variable. I'm supposed to find this. I was only given one item. I'm supposed to use this. What do I do? Oh, gosh, that makes such logical sense. I think I like that. I'm going to put that here, and then I'm going to put that in there, and that means square. Okay, now what do I do? Oh, wait. It's just math.
Divide.
Come on, guys.
Divide the side by.
No. Come on, guys. Come on. How about I just square? Just square 6/7, right? Don't leave it that way. Okay, so now you have to do it. So that's your homework.